Okay, here we go. An AND statement is an intersection statement. An OR statement is a union statement. Okay, AND intersection, OR union. So AND intersection, you're looking for where the two overlap. OR union, you're just putting the two sets together, combining them. Again, next problem is an OR statement. So we're looking for the union of the two sets. Clear. 4 minus 3x is less than negative 2. The only difference here again, the only thing you have to do different is when you divide by negative, flip your symbol. 4 and negative 2 are like terms. To move 4 from one side to the other side, it's a positive 4, so let's turn it into minus 4. You now have negative 3x is less than negative 6. Divide by negative 3. Since you are dividing by a negative, flip it over. X is greater than 2. Or, that's AND. Try again. The second one, you can distribute there. Okay, if you want to, 3 times x, 3 times 2. What I would do is just go ahead and divide by 3. Since the whole side is being multiplied by 3, divide the other side by 3. 3 is a positive number. Do not flip it. To get rid of minus 2, we're going to add 2. Gives me x is less than or equal to 0. Did we work this one yesterday? I think we did, didn't we? Here's 0. Here's 2. We're going to union all the numbers greater than 2. There's all the numbers greater than 2. We're going to union that with all the numbers less than or equal to 0. So that would be all the numbers from negative infinity up to 0, including 0, along with all the numbers from 2 to positive infinity. Any questions? When it's written as a sandwich, there's two different ways to work this. And what I mean by sandwich, you got negative 4 is less than or equal to stuff, which is less than 5. This stuff is bigger than negative 4. This stuff is also smaller than 5. The hard way of working it is to split it. Negative 4 is less than the stuff in the middle. And also, anytime it's a sandwich, it's an AND statement. Here's how you remember. Sandwich, right? Sandwich is an AND. The stuff in the middle would also be less than 5. So pretty much share the middle. The middle is greater than this. The middle is less than this. Work it twice. Make it an AND. The easy way. And sometimes this is not possible. Most of the time it is, though. To get x by itself in the middle, we got to get rid of minus 1. We got to get rid of this 3. The easy way of doing this is moving the minus 1 out of the middle. But the only problem is you really have 3 sides. So when you move it out of the middle, you're going to do plus 1 here, and you're going to do plus 1 here. Everything that's not in the middle, you're going to add 1 to it. You now have negative 3 is less than or equal to 3x is less than 6. You see where I'm going with this. To get rid of the 3 that's on the x, divide by 3. Divide everything by 3. Divide that by 3, it's gone. Gives you negative 1 is less than or equal to x is less than 2. Isolate the x in the middle by adding 1 to everything. Divide 3 into everything. So you have x is bigger, and this bothers me. Guys, you normally read these left to right. But if x is on the right side, read it this way. X is bigger than negative 1. X is greater than or equal to negative 1, so let's draw that. Here's negative 1, here's 2. X is bigger than negative 1, and also, well, if you want to keep drawing, that's all the things bigger than negative 1, and also x is smaller than 2. There's all things smaller than 2. It's an AND statement, so you're looking for the intersection. The intersection is the middle. Or you can, again, think of a sandwich as, if x is in the middle, it's between negative 1 and 2. It's all stuff from negative 1 up to 2. So solution set looks like this. All values from negative 1, including negative 1, up to 2, not including 2. Any questions? Been there, done that, right? I think these are probably no solution or infinite solution problems. I'm just going to fly through it. Add 9 divided by 3 gives you x is less than or equal to 6. Or union. I'm going to move x over here. Subtract 3. That'll be x is greater than or equal to 1 when I flip it back around. Yeah. So we're going to union all numbers bigger than 1 and all numbers smaller than 6. Here's all the numbers bigger than 1. Here's all the numbers smaller than 6. Put all those numbers together. As a solution set, you'll get all values from negative infinity to positive infinity. It's a union problem. Had that been an intersection problem, it'd just been the middle, right, from 1 to 6. But since all numbers here plus all numbers here, that would be an infinite solution problem. You could also put all real numbers there. This one's probably going to be right the opposite. Divide by negative 2/3, that's multiplying by negative 3/2. Make sure you flip your symbol over. Gives you negative 6. And divide by 3/4, that's negative 24/3. Notice I did not flip my sign over. That's the common mistake here. You're dividing by 3/4. 3/4 is not a negative number. Okay, it's what you're dividing by. Negative 6 is not what you're dividing by. It is a negative, but you're dividing by 3/4. So don't flip your symbol over there. I think you get negative 8. So we're looking for intersection. Upside down, U, that's intersection. We're intersecting all the numbers smaller than negative 8, bigger than negative 6. Smaller than negative 8, bigger than negative 6. There is no intersection. No solution. Okay. Now, I'm teaching this part very different from the way the book does. So if you look in the book and try to follow along with what I did, it's completely different. This is the reason I wanted you to learn about the graphs. Okay, you have an absolute value graph. Reminder, this will be part of your review. The absolute value graph is a V-shaped graph. 7 is a horizontal line. We're looking for where is the absolute value. Where is the V graph less than? That's below. Where is the V graph below the horizontal line? Well, that'd be the middle. Everybody understand that? Everywhere from here up to here, and it'd actually be open surface. The only problem is we need to know where is here and where is here. This and this is where the V graph crosses the horizontal line. So my very first step when you're solving absolute value inequalities is you actually solve the absolute value equation. And this, again, we won't have to review this. If you'll watch it now, if you have any questions about it, ask it now. We won't have to review this because this is part of your test. Okay, how do we solve absolute value equations? You split it. 3x plus 2 is 7, and 3x plus 2 is negative 7. We solve each. Subtract 2 divided by 3 gives me 5/3. Subtract 2 divided by 3 gives me negative 3. Now what did that tell us? My graphs are equal. And equal means they cross. My graphs cross at x equals negative 3 and at x equals 5/3. But the question was not where they're equal. The question is, where is the graph of the V below the horizontal line? Anytime you have less than, guys, look, from here to here. Does everybody understand? The V is below the line here to here. So what's my answer? All the values from negative 3 up to 5/3 in the middle. Not including, not including. Why did I not include? Because it's less than, not less than or equal to. Here's you another one. First step, make sure, get that absolute value by itself. We can clean it up as much as possible before you start. Move the negative 2 over. So now you have the absolute value of 4 minus x. When you do, this is multiplied, something else. Don't distribute that. Okay? We're not taking the absolute value of negative 2. It's not inside, but if you distribute that, all of a sudden it's inside. Okay, don't do that. Negative 2 is being multiplied by this absolute value, so move it to the other side by dividing. When you divide by -2, make sure you flip your symbol over. So there's my problem now. The absolute value is greater than +2. Absolute value, 2. We're looking for where's the absolute value above the line. It's above the line here, and it's above the line here. Everywhere to the left of this point, everywhere to the right of this point. So my solution set's going to look like this. All these x values and all these x values. Let me rephrase that. All these x values or all these x values. Not and. Can't be and. There's no overlap there. So what do I do now? I need to know what are these actual values. So I set it equal to 2. I do the absolute value of 4 minus x equals 2. I split it by doing 4 minus x equals 2 and 4 minus x equals -2. The way I solve this equation is I move my x over. I don't move my numbers over. I'll move my x over, move my 2 to the left. When you move minus x, it becomes a positive x. When you move 2, it becomes a -2. So that would give me x equals 2. Or, how often do we overcomplicate this stuff? 4 minus some number equals 2. We went through all that difficult stuff to figure out 4 minus what number is equal to 2. Do we not do that a lot? 4 minus box equals 2. I believe my son does that in first grade. All right. Same thing here. I'm going to overcomplicate it. Minus x becomes positive x. Minus 2 becomes positive 2, and I believe we get x is 6. So my numbers here are 2 and 6. That's not a 6, that's a 2. Good morning. Morning. So here we go again. I changed that now, 6. My values, my solutions are all the numbers to the left of 2. Because again, we're looking for where is my v above this line. Here's 2, here's 6. Everywhere from the left of 2 or to the left of 2, it's above it. Anywhere to the right of 6, it's above it. That'd be all values from negative infinity. That's that arrow. Goes forever. From negative infinity up to 2. Or all the values from 6 to positive infinity. Which is pretty much all values except for the numbers from 2 to 6. Why not the numbers from 2 to 6? Because 2 to 6 is where the v is below the line. My bad. Since it is or equal to, thank you very much. Since it is or equal to, we do have to include these 2 digits, so those should be brackets. Thank you very much. Any other questions or comments? Okay, on these problems, let's use common sense to solve them. You can do it the exact same way, but again, think common sense. Where is the absolute value greater than -3? And we'll take a stab at that before we even start it. Where is the absolute value greater than -3? Everywhere, right? Can absolute value ever be negative? This right here will always be a positive number, right? So where will it be bigger than -3? All real numbers. You can either put all real numbers, or you can put all values from negative infinity to positive infinity. Now the other scenario that you might have, what if that was a less than? Where's the absolute value less than a negative? No, nowhere, no solution. So those are your quick, easy problems. If you solve that, if you set it equal to -3, you're not going to get any answers. So that's going to be kind of confusing. But if you can recognize the absolute value greater than negative, it's always greater than negative. Okay. Those are absolute value inequalities. Here we have quadratic inequalities. To solve a quadratic inequality, first step is the same thing. You have a parabola. Well, let's move this 6 over to the other side. When solving anything quadratic, if it's got that middle term x, go ahead and move that constant term over, not or equal to, and get you a 0 on one side. So now what we're looking for, where is your parabola? That's a parabola. Where is it above 0? Well, here's your scenario. The 0, that's going to be your x-axis. Right? We're looking for where is my parabola, and it's a positive cut parabola. It's an up-shaped parabola. Where is that parabola above 0? Well, I know for a fact here's where it's equal to 0. So where is it above 0? Well, not in the middle. Okay, in the middle is where it's below 0, so where is it above 0 would be on the outside. So these problems, like I said, these problems are actually identical to the ones we just worked, except for instead of a V, you have a parabola. Well, first step is to find out where it's equal to 0. The way we do that is we set it equal to 0. Let's go ahead and factor as we're setting it equal to 0. You can solve quadratic equations by factoring, or quadratic formula is the best two methods. Or you could complete the square if you'd like. Or you could graph it. If you have a graphing calculator, graph it and look for your intercepts. Negative 3, positive 2 adds to give me a negative 1, multiplies to give me a negative 6. We split it. X minus 3 is 0. X plus 2 is 0. You don't have to show that step if you don't need to. And you get x is 3 or x is negative 2. So those are my two intersection points. This is negative 2. This is positive 3. Put them in order, please. So my solution set would be all values from negative infinity, and I'll check it this time. Since it's greater than, no or equal to, don't include negative 2. From negative infinity to negative 2, or from 3 to positive infinity. Everywhere except for negative 2 up to 3. Any questions on how we do that? Yeah, because if it were the middle section, it would be all the numbers from negative 2 up to 3. Okay, it wouldn't stretch, it wouldn't range all the way to infinity. That makes sense. Now here, all numbers greater than 3, yeah, that keeps going. Because this parabola keeps going up forever. Okay, so over here, no matter how big x gets, that parabola is still above your x-axis. Same thing over here. It keeps going up here. It's always going to be above that x-axis. Is that the same problem? It is. Except for it's less than or equal to. Let's just go back and solve it here, guys. The next problem, where is that parabola, if you move that over, where is the parabola less than or equal to 0? Well, that'd be the middle, right? So that would be just the values from negative 2 to 3. Without going through all that problems of solving that again. The middle values would be where it's less than or equal to. Now could I, instead of moving that 6 over, if I wanted for some reason x squared minus x is less than or equal to 6, if you wanted to leave it like that, you're going to get the same answers. I think this might be, let's see how many more we got. Got 2 more. X squared plus 6x is greater than or equal to 0. You have a parabola, you have 0, which again is the x-axis. We want to know where's that parabola above 0. It's going to be above 0 everywhere from here over and everywhere from here over. It's above 0 everywhere but the middle. We factor and we get x plus 2 and x plus 4. We set that equal to 0 to find out where it actually crosses. Solve that, you get negative 4 and negative 2. So your parabola will be above the x-axis everywhere from negative infinity up to negative 4, including, because it's or equal to, all the values from negative 2 up to infinity. So again, all values except for the values between negative 4 and negative 2. Now let me just show you again what you actually found there. Negative 3 is not a solution. If you plug in negative 3 here, it should not work. Try it. Negative 3 squared is 9. 9 minus, that's 18, plus 8. 17 minus 8, that gives you negative 1. Is negative 1 greater than or equal to 0? No, it's not. If you plug in any values in here, it will not work. If you plug in any values on the outside, it will work. Okay, it will always be greater than or equal to 0. That's your plug in. Last one. This will be a fun one. Anytime you see the number out front, this will be also a good review problem. The number out front indicates you must do bottoms up on this. If there is a number out front, move it to the end to factor it. This would be x squared minus 4x minus 18, which goes along with the problem that was on the sideboard over here yesterday. When we moved it to the end and we factored it, we didn't go back and divide. Okay, look at this. X squared minus 4x minus 18. Multiplies give you 18, negative 18 adds to give you negative 4. Anybody? I hope not, right? That doesn't factor. So my method, I would try bottoms up first. Okay, if bottoms up works, awesome. If bottoms up does not work, what's my next method? Any ideas? Quadratic formula. Thank you. And you will have your formula sheet on the test, so you can use it. Quadratic formula says negative b plus and minus the square root of junk over 2a. And again, I remind you, do junk first. Junk is b squared minus 4ac. B squared is 16 minus. I always write that minus down because that's built into my formula. 4 times A times C, 4 times 2 times negative 9 gives me negative 72. Add those, 88. Since my junk here was 88, that shows me why that didn't factor. I don't know what the square root of 88 is. Had you got a number like 81, 100, 36, 64, that would have factored. But since the stuff under the radical is 88, that will not factor. So now let's go back and plug this in. Negative b would be positive 4, plus and minus square root of 88. Let's go ahead and clean that up. Square root of 88. What can I break? Caleb Haynes. My perfect roots. 4, 9, 16, 25. Which of those numbers is located in 88? 4. We're going to split it into the square root of 4 times something. Let's split it into the square root of 4 times the square root of 22. Everybody good with that? And I have no idea anything that's in 22, so that's as far as that'll simplify. Over 2 times a, and a was 2, so 2 times 2 is 4. Now that will simplify. You can split that. Here's your options. When you're cleaning these up, you can split it if you want to and do 4 over 4 and 2 root 22 over 4. What I would do, there's 3 terms there, guys. 4 is a term. 2 root 22 is a term. 4 is a term. I see a 2 in all of those. Reduce this fraction. Divide everything by 2, and you're going to get 4 divided by 2 is 2. 2 root 22 divided by 2 is just root 22. And on bottom, 4 divided by 2 is also 2. There's your 2 answers. So, let's see what we have. You have a parabola less than 0. Where's my parabola less than the x-axis? Does everybody understand where that's going to be? From here to here. The middle is where it's below. My parabola is below the x-axis everywhere from here to here. Okay, there's your 2 answers. Which one's here and which one's here? Any idea? What would this one be? Because my answers are 2 plus root 22 over 2 and 2 minus root 22 over 2. Which one would this be? Common sense, guys. Would it be the plus or the minus? The minus. Does everybody understand? When you take it away, it's going to get smaller. So this would be 2 minus root 22 over 2. And this answer here would be plus root 22 over 2. So the way that they're probably going to list it on the test would be all values from, where is it below, all values from 2 minus root 22 over 2 up to 2 plus root 22 over 2. That is not a point. That is an interval, everywhere from here to here.